Hi there, this video is about the estimation of mean group, pool mean group, and dynamic fixed effects estimators in Stata. These are the estimators that we can use once we have estimated the first generation panel unit root tests like LLC and IPS. We have already learned how to do these on Stata in our last video. Now we will proceed towards these estimators. So the basic comparison of these three estimators. In MG, that is mean group analysis, the coefficients are considered to be different across the groups but constant over time. But here in the DFE, they are considered variable over time. And the coefficients are constant across the groups. So this is the comparison between these two. We must not overlook the presence of pool mean group PMG. In this, the long run coefficients are assumed to be identical, that is constant or same, but the short run coefficients, they are allowed to be variable across the groups. So these are the basic postulates of these three techniques. We can estimate all three of them, and then we can compare the results and choose the most suitable. And in this video, we will also learn that how we can choose the most suitable in each case. This is the reference of these two techniques, and this is the reference of this technique. Now coming to the syntax of these techniques, we have 5 commands that we will run, but actually there are 3 techniques to be estimated. These 2 commands are used to make the suitable choice among the 3. The command is XT-PMG. XT stands for panel data, countries, time dimension. PMG stands for pool mean group. And afterwards, we will write the dependent and independent variables. We have chosen only one independent variable for the sake of ease. And the difference operator is used for the sake of short run coefficients, as we know that in this case, we will also get the short run coefficients. Long run coefficients, they are also there. Long run coefficients with the dependent variable and the independent variable. For lag dependence, because this is a dynamic panel model, we have this lag operator L dot and definitely the dependent and the independent variables. Then we have the estimation of the error correction term. We have written newly created because we will be calculating 3 of these, each for the 3 techniques, and this is why we are mentioning newly created, because it will be created thrice. And then replace operator is used. It is useful because once we calculate this and we give it a certain name, that is ECT, it will be stored in the data. And when we go towards the other technique, there will be another ECT. So this will be a contradiction, and we have to delete the previously generated error term. This is why if we use replace, it will overwrite this pre-existing or pre-calculated error term, and we don't have to delete the data again and again. So this replace should be used every time we run this command. So this is the explanation of it. And finally, the estimator that we are estimating. Here we are estimating MG, and then we can estimate PMG. As you can see, the remaining things, they are the same. Once we have estimated these two, we can compare between them, the one which is more efficient. For that, we have Houseman test. The command says Houseman. MG is the first estimator, PMG is the second estimator, and then this keyword sigma more is basically for the adjustment of covariance matrix. Once we conduct this, we will be able to get the results and compare which one of these is more efficient. Then we have the third estimator. Again, the full command is the same. The only difference is with this estimator, that is DFE, dynamic fixed effects. So afterwards, we have the Houseman command once again being conducted, when we will compare MG again with DFE, and sigma more again stands for the same covariance matrix, its adjustment. From the empirical literature, we have chosen this article. We used this for the first generation panel unit root tests, and here we have used these estimators. You can see that we have mentioned these estimators here, and these are a few background technical informations, and then we have the comparison of the three techniques, the MG, DFE and pool mean. There are long run parameters and there are short run parameters, and there is a convergence parameter. The error correction term can be used here. So these are the long run parameters and these are the short run parameters, the error correction term and its usage for the sake of convergence parameter and adjustment time. These are the number of observations, groups, and here we have the p-value of the Hausman test that we were discussing, MG and DFE. So the two tests, they are conducted here. Another example from the empirical literature where the same tools are used. So you can see MG, DFE and PMG, the long run, the convergence term, and then the short run parameters, the Hausman tests. All these things, they are estimated and used here. For a more detailed understanding of the Hausman test, you can understand it from this article. It's quite detailed when it comes to the selection of MG and PMG and DFE. So you can pause the video and you can note this. So I'm going to use my own hack of writing all the commands together and then pasting it in Stata and running it in one go. This is the first command for the estimation of MG, and as I have already explained the command. And then we have the other command, that is PMG, and then the comparison of MG and PMG, then dynamic fixed effects, and the comparison of MG and DFE. So let's run these commands here. So the commands are pasted here, and we are going to run these commands. The first one is being run. The second one, for PMG, there are some iterations, as you can see. It takes some time, not much, but sometimes more. So we'll have to wait a little. 3 iterations, 4 iterations. So one has to be patient for this. Now the other commands are also run instantaneously. So now we can understand the results. So this was the first one, the MG. This is the long run coefficient for X. This is the coefficient, not statistically significant. The error correction term, less than 1, negative, desirable because it is statistically significant. Here the short-term coefficient, it is statistically significant. Then the PMG would have a similar sort of structure, long run coefficient, error correction term, and the short run coefficient. And then the comparison of Hausman test, it is statistically insignificant, so it is desirable in the sense that it indicates that PMG is more desirable as compared to MG. In that last visual of that article, the details of these comparisons of Hausman are given. Then the dynamic fixed effects model, again the long run coefficient, the error correction term, and the short run coefficient. And finally the comparison of MG and DFE, which is statistically insignificant, which means that again the DFE is superior than MG. So the question between PMG and DFE remains. For that, the reason is that PMG estimator dominates DFE because it permits the heterogeneity in the short run coefficients. So this makes PMG superior to DFE, and already PMG and DFE are already found to be superior than MG. Therefore, PMG is found to be more efficient than the two estimates. Now this is a bonus, and you have seen in the empirical literature, country-specific effects are estimated. So this is another published work in the quarterly review of economics and finance, and in this we can see those country-specific effects. So this is the table from this article, and we will see that there are 4 possibilities. The first one is expected country-specific effects. It means that the statistical significance is there as well as the slope is according to the expectations. That is, in this case, a positive relationship. But in this case, the statistical significance is there. However, the expected sign is not there. This is why we call it unexpected country-specific effect. Another possibility is that the statistical significance is missing, whereas the sign is desirable. That is a positive relationship in this case. The final possibility is that it is neither statistically significant nor having a desirable sign. It is opposite to our expectations. Therefore, we call it inconclusive because of the lack of statistical significance, and unexpected sign is also there. So these are the four possibilities that can allow us to delve deeper into the country-specific analysis, and it is done in this published article. Another example of such article is there. So this is that another article in which the country-specific effects are found. Here you see that this allows us to have all those four possibilities, and very interesting for interpretation, because when you start interpreting these country level coefficients, they can really give you country specific effects and details and insights which are usually absent in our panel data analysis. So for that, we simply have to add the keyword of full, as you can see at the bottom of the screen, at the end of the command, and it will give you the country specific coefficients. And I'm going to use MG estimator for this, not PMG or DFE. Doesn't work on DFE, works on PMG, because I'm choosing this because MG allows the heterogeneity or the different coefficients at cross-sectional level, in this case at country level. So this is in lines with the assumption. Therefore, let's just run this command and see. It's going to run, as you can see. Now you can see that this is for the first identifier, the first country, and this is for the second country. For first country, the long run coefficient, error correction term, and the short term coefficient. Same stand for the second country, the long run coefficient, the error correction term, and then the short run coefficient. So you see, for all these countries, I'm going to click this more. The 6 countries, 8 countries, 10, 12, all these countries, they will be listed here. Their long run, short run coefficients, as well as their error correction term. So you can extract these long term coefficients and then interpret them as per their results, that is expected and unexpected, conclusive and inconclusive results. So I hope you have found this meaningful. You have learned a few things from the empirical literature as well. Don't forget to subscribe, share, and like this. And thank you for watching.